So lesson number 6 looks at specific identities, sum and difference identities. So what we have here on the page is just that chart again of some of the exact values that we can use as we're going through this. So the first thing is it says consider the statement sine A plus B equaling sine A plus sine B. So it says determine whether or not I can verify the statement if angle A is 60 degrees and angle B is 30 degrees. So the left-hand side says that I go sine 60 plus 30, which would be 90 degrees, and the sine of the 90-degree angle is equal to 1. Then if I look at the right-hand side, I've got sine 60 plus sine 30. And according to my chart, the sine of a 60-degree angle is root 3 over 2. And the sine of a 30-degree angle is 1/2. So if I add, the denominators are the same, I get root 3 plus 1 all over 2, which is not equal to 1. So I cannot verify the statement. So this cannot be verified with the values that I'm given. So what can we say about this statement? We can say that the statement is false. So then what we are going to do is we are going to use exact values to verify the next 4 statements. And because it says to verify, the implication is that they are true. Okay? So with this first one, I've got sine 60 plus 30, which is sine 90, which is equal to 1. So that's on the left-hand side. Then on the right-hand side, I've got sine 60 cos 30 plus cos 60 sine 30. So sine 60 is root 3 over 2. Cos 30 is also root 3 over 2. Cos 60 is 1/2. And sine 30 is 1/2. If I take root 3 over 2 and I multiply it by root 3 over 2, what would I get? 3 over 4? 3 over 4. And 1/2 times 1/2 would be 1/4. And 3/4 plus 1/4 equals 1. So I've shown that both sides are equal to each other. So if I look at number 2, I have sine pi over 3 minus pi over 6. So if I was to subtract these using common denominators, I would get 2 pi over 6 for my pi over 3 minus pi over 6. This would leave me with sine pi over 6. And again, according to my chart, sine pi over 6 is 1/2. So there's my left side. And then according to the right side, I get sine pi over 3 cos pi over 6 minus cos pi over 3 sine pi over 6. So sine pi over 3 is that root 3 over 2. Cos pi over 6 is root 3 over 2. And then cos pi over 3 is 1/2. Sine pi over 3 is 1/2. So it's almost the same as the equation above it, except now I'm subtracting. So I would get 3/4 minus 1/4, which equals 1/2. 2/4, which reduces down to 1/2. So we've proven, or we've verified this statement. Not proven it, we've verified it. Then if we look at the next one, I get cos 30 plus 60 degrees, which would be cos 90 degrees, which is equal to 0. And we're verifying that equaling cos 30, cos 60 minus sine 30, sine 60. So cos 30 is root 3 over 2. Cos 60 is 1/2. And then sine 30 is 1/2. sine 60 is root 3 over 2. So when I multiply this together, I get root 3 over 4 minus root 3 over 4, which is equal to 0. And then the last one, I get cos pi over 2 minus pi over 4. Again, if I'm going to subtract these, I need a common denominator of 4. And I get cos pi over 4. And cos pi over 4 is root 2 over 2. So that's what the left side would be equal to. Then on the right side, I get cos pi over 2, which is equal to 0. Cos pi over 4, which is root 2 over 2. And then I get sine pi over 2, which is 1, times times sine pi over 4, which is root 2 over 2. 0 times root 2 over 2 is 0, so that disappears. And 1 times root 2 over 2 leaves me with root 2 over 2. So again, I've verified the last two statements. If you turn the page, what it says is these 4 statements are part of 4 sum and difference identities, which states that the sum of two angles can be written as sine A cos B plus cos A sine B. The difference becomes sine A cos B minus cos A sine B. And then when it's the sum of my cos angles, I get cos A cos B minus sine A sine B when I'm adding them. And when I'm subtracting them, it's cos A cos B plus sine A sine A sine B. You are not expected to prove these identities. The identities are provided to you on your formula sheet for your reference. Where these come in is these allow us to find the exact value of an angle that otherwise I wouldn't be able to. An angle such as 15 degrees. If you ask me to find the exact value of sine 15, I don't have the ability to do that right now. If I went sine 15 on my calculator and tried to square that answer, it would not help me. Okay? However, 15 degrees I can write as 45 minus 30. So then I could use this and I could find sine 45 cos 30, cos 45 sine 30. And I could use the exact values because I have those exact values. So if we use the exact values from the chart that's on the top of the first page, I can use that to help me find the exact values of some of these more obscure answers. Okay? Then there's also the tan, the sum and difference for a tangent. And it says here the sum and difference identities for sine and cosine can be used to develop the sum and difference identities for tangent. So we're going to actually do both of them, tan A plus B and tan A minus B. So with the tan A plus B, this is what I want to show that it equals. So I start off with tan A plus B. Well, tan is the same as sine over cos. So I get sine A plus B and cos A plus B. So I rewrite sine and cos. And then what I'm going to do, is I'm going to divide the numerator and the denominator by cos A cos B. So if I divide by cos A plus cos B, what I end up with is I'm going to actually separate it. So sine A cos B divided by cos A cos B plus cos A sine B over cos A cos B. And then this is all over, and I'm going to separate this out. Cos A cos B over cos A cos B plus sine A sine B over divide by cos A, cos B. If I divide the numerator and the denominator by the same thing, I haven't actually changed the value. Because it's like dividing by 1. What can I cancel out in this first term?
Cos B.
The cos B's. And what would sine A over cos A equal then? Tan A. So I get tan A. And then in the second term, the cos A's cancel, and so now I have sine B over cosec B, which would equal tan B. So I got tan A plus tan B over cos A, cos B over cos A, cos B equals what happens here? If I take something and divide it by itself, what do I get? 1. The last term, nothing can cancel. Well, what's sine divided by cos? So I get tan A, tan B, which is what I was trying to prove.
Shouldn't it be
Oh,
subtraction?
should be subtraction. Where did? Oh, right here. There's my minus. Sorry. There. Okay, so we're going to do something similar for tan A minus B. So tan A minus B will start off as being the same as sine A minus B over cos A minus B. And if we go up to the top of the page, what is sine A minus B equal to? Can you read it out, Evan?
Sine A cos B minus cos A sine B.
And then what's cos A minus B?
Cos A times cos B plus sine A times sine B.
Okay. The next step, we're going to do like we did before. We're going to divide the numerator and the denominator by that cos A, cos B. So when I write it out, I'm going to separate everything. Sine A cos B over cos A cos B minus cos A sine B over cos A cos B, and then I get that division bar cos A cos B over cos A cos B plus sine A sine B over cos A cos B. And then we're going to cancel out all of the things that we can cancel out, such as cos B divided by cos B, cos A divided by cos A. All of this cancels out all of that. So what's sine A over cos A? Tan A. And sine B over cos B?
Tan B.
So I get tan A minus minus tan B over, what do I end up with here when I cancel the top and the bottom out?
1.
And sine over cos A, and then sine B over cos B, and there's the other identity. So again, these two are also on the formula sheet. So it's not so much how do you get them, it's now how do we use them. So we have a series of examples of how we can use them. So the first one is exactly what I was talking about before, 15 degrees. Express 15 degrees has a difference of 2 special angles, and then determine the exact value of sine 15 degrees with a rational denominator. So 15 degrees. When they're talking about your special angles, we're talking about 0, 30, 45, 60, and 90. So what combination of those numbers would give me 15 degrees?
45 minus 30.
45 minus 30. So 15 degrees can equal 45 degrees minus 30 degrees. So then sine 15 degrees can be written as sine 45 minus 30. So now if I use that sign difference identity, so the sign difference becomes sine A, which is 45, cos B, B is 30, this one is the minus cos A, which is 45, sine B, which is 30. I should put degree symbols in all of these. Now, what is the exact value of sine 45?
Root 2 over 2.
Root 2 over 2. What about cos 30?
Root 3 over 2.
Right? Cos 45.
Root 2 over 2.
And sine 30. 1/2. 1/2. Good. Okay. Root 2 over 2 times root 3 over 2 would equal
6 over 4.
root 6 over 4. Okay? The square roots don't cancel each other out because they're not the same radical. Minus, what's root 2 over 2 times 1/2?
Root 2 over 4.
Denominators are the same, so I can combine them and get root 6 minus root 2, all over 4. Is 4 a rational number? Yes. Because it's a rational number, I have a rational denominator. What they're saying is I don't want a root down here. Okay? Your calculator would not be able to give you that. It wouldn't have the programming to write that as root 6 minus root 2 all over 4. And there's no special calculator keys that I could use to help me get to that because we're talking about an expression. Oh, sorry, I want to go back to this. The radian measures are the harder ones to do because they're dealing with fractions, and we never really like fractions. So if I go back again, this is 0, pi over 2, pi over 3, pi over 4, and pi over 6. So I have 4 different denominators here. Do these 4 denominators have a common one? Do I have a common multiple for 6, 4, 3, and 2?
12.
12. So I can write everything as being something over 12. So pi over 6 becomes 2 pi over 12. What would pi over 4 become?
3 pi over 12.
And pi over 3?
4 pi.
And pi over 2?
6 pi.
Now that I have everything as 12s, asking you to come up with a combination of 5 pi over 12, how would I do that?
2 pi over 12 plus 3 pi over 12.
So 2 pi over 12 plus 3 pi over 12, which is that pi over 6 plus pi over 4. So those are my special angles, and now I want to show that cotangent equals the following expression. So what is cotangent equivalent to?
Cos over
Cos over
sine.
sine, or what else?
Inverse of tan.
It's the inverse of tan. So cotangent 5 pi over 12 is going to be 1 over tan 5 pi over 12, which is 1 over, so what I'm going to do is instead of putting this all as 1 over, we're going to deal straight with tan 5 pi over 12, and then we'll worry about inverting it afterwards, or taking the reciprocal. So this becomes tan pi over 6 plus pi over 4, A plus B. So in our formula, tan A plus B becomes tan A plus tan B over 1 minus tan A tan B. So what is tan pi over 6?
Root 3 over 3.
Root 3 over 3. And what's tan pi over 4?
Mm,
1. And then on the bottom, I have 1 minus tan pi over 6 is root 3 over 3 times tan over pi over 4, which is 1. So I'm just going to leave this as 1 minus root 3 over 3. So what I'm going to do now is if I combine this and write this as an expression, so use a common denominator, my common denominator would be 3, and I would get 3 minus root 3 over 3, and then this one would be root 3 over 3, or sorry, this would end up being root 3 minus 3 over, sorry, plus 3. There we go. Dividing fractions is multiplying by the reciprocal. So we've got root 3 plus 3 over, I have to divide by the reciprocal, or multiply by the reciprocal, because I have common denominators. So these two denominators would cancel out, and that would leave me with root 3 plus 3 over 3 minus root 3. So if that's what tan equals, cotangent would equal the reciprocal of that. And I would get 3 plus, or sorry, not 3 plus, 3 minus root 3 over root 3 plus 3. Which does simplify to this with a whole bunch more steps, and I'm not going to do all of those additional steps. We're just going to leave it where it's at. What I could do is I could go 3 minus root 3 over 3 plus root 3 and just change these around because they're both the same. And then that way I've got kind of my rational numbers and my irrational numbers stacked. Okay, class example 4 is a little bit easier because with class example number 4 you're working backwards. You're taking the right-hand side and writing it as the left-hand side. So if I look at this, I have sine 100 cos 10 minus cos 100 sine 10. So if I look at the right-hand side of those identities, what does this match up to? This is sine A minus B. So this would then be sine 100 minus 10 degrees, which is sine 90 degrees. And what is sine 90 degrees? 1. Which is a lot simpler than having done all of those other calculations. So if I look at B, I have cos 1, or pi over 4 minus theta, cos pi over 4 plus theta, minus sine pi over 4 minus theta, sine pi over 4 plus theta. So ignore this part in here as being a whole bunch of stuff and just worry about the pattern. Cos, cos minus sine, sine. This is cos A plus B. So A is pi over 4 minus theta, and B is pi over 4 plus theta. So if I add these together, what's pi over 4 plus pi over 4?
2 pi over 4.
So I get cos 2 pi over 4. And what's negative theta plus theta? Zero cancels out. So I get cos pi over 2, which is equal to 0. Okay, the last one. Given that cos A equals 3/5 and cos B equals 5/13, where A is between 0 and pi over 2, and B is between 3 pi over 2 and 2 pi, find the exact value of cos A plus B. do you think we should do first? First of all, where is angle A located?
In the first quadrant.
In quadrant 1. So let's draw it out. So in quadrant 1, I have cos A. So there's angle A. And what do I know cosine stands for?
Adjacent over hypotenuse.
Adjacent over hypotenuse. So the adjacent side is 3, the hypotenuse is 5. Can I solve for the opposite side? How?
5 squared minus 3 squared. So 25 minus 9 is 16. So 4.
Good. So 5 squared minus 3 squared, 25 minus 9 is 16, square root of 16 is 4. Good job. Okay, so that's angle A. Where's angle B located? Quadrant 4. So let's sketch what that looks like. So there's my angle B. And from before, we know that cosine is the adjacent over the hypotenuse. Can I calculate the opposite side? Okay. But if I'm in quadrant 4, what can you tell me about that 12?
Oh, negative 12.
It's going to have to be negative. And the only way I would know that is knowing what quadrant I'm in and being able to sketch it. Otherwise, I wouldn't really know that it's supposed to be a negative 12. Okay? What is cos A plus B equal to, according to my identities?
Cos A times cos B minus sin A times sin A.
I was told what cos A equals. Cos A equals 3/5. I'm also told what cos B equals. Cos B equals 5/13. So if I go back to sine A in quadrant 1, what would that equal? 4/5. And if I go to sine B in quadrant 4, what would that equal?
Negative 12, 13.
So now I can substitute those values in. So sine A becomes 4/5, and sine B is negative 12/13. Now in this step here, I'm going to straight multiply this. I'm not going to worry about simplifying it yet. Because I know I could cross out those 5s, but the reason why I'm not going to cross them out is because I can't really cross anything out here. And if I multiply straight across, I'm going to get this 5 times 13 and this 5 times 13. So then I'm going to be able to combine because I'll have common denominators. So that's 5 times 13.
65.
And 3 times 5?
15.
And then 4 times negative 12. minus negative 48, what can I write?
Plus.
Plus 48. So I can change this to a plus 48. And what is 15 plus 48? 63. So yeah, 63 over 65 is the exact value of cos A plus B. I have seen a question like this on almost every diploma I've ever looked at, where it gives you the value in two different quadrants and then asks you to find, sometimes it's a sine A plus B or minus, or it could be a tan, but they start off by giving you part of this. And so it's the same process. Sketch what it looks like, complete the rest, and just know that cos A equals 3/5. It's not cos A all of a sudden becomes cos 3/5. That's not what it's equaling here. It's saying instead of writing cos A, I can now write 3/5. And that's the most common mistake that I see happen, is the 3/5 all of a sudden gets put in for A, and it should get put in for cos A.
How did you know what quadrant we were in?
The domain's right here. So pi over 2 is 90 is the first quadrant, and then this right here is the fourth quadrant. So they will give you, you will be given that information. Okay?